So how do we model externalities? So again, always be thinking, you've got this market diagram with the market cross, demand and supply. How are we going to try to bring this new scenario, this externality, into a market diagram? Well, what we're going to say here is that, think about this demand curve we've always drawn. The demand curve we've always drawn is what I call private D here. Private D means what is the value to the individuals making the market choices. That's my own private value. That's my bargaining between myself and my gardener about how many times a year to mow my lawn. However, and in most cases, the private D represents the value to society, right? The value to society of a cup of coffee is a value that I place on a cup of coffee. It's not really, we don't really think that there's externalities around cups of coffee. But here in this case, we might think about this lawn, that there also is a value not only to you, but all your neighbors from you mowing your lawn. So there's actually another demand curve, which is further out or higher up, whichever way you want to think about it. This other one is called social D. So this is the value to society of my lawn being mowed. And it's greater than the value to me. Because it's a value to me, plus it's a value to all my neighbors. How much do my neighbors gain in terms of property prices if I mow my lawn more frequently? So there's a social demand curve and a private demand curve. And the problem here is that when I'm thinking about how many times to mow my lawn, I look to my private demand curve and I look and see where the private demand curve and the supply curve hit. And that's where I choose my market quantity. But that's not the socially optimal market quantity, because that ignores the impact of my decision upon everyone else. The socially optimal quantity is a much higher quantity, where the social demand curve and the supply curve cross. So if we could get together, if my neighbors could convince me, we'd all agree that, in fact, my lawn should be mowed the socially optimal number of times, not my privately optimal number of times. And that's what my neighbors, what their neighbors were explaining to my friends, that they wanted my friends to mow their lawns more frequently. Right, so typically when we're thinking about this is a case of what's called a positive externality. My decision or my actions to mow my lawn more frequently would generate benefits to other people. So it's a positive externality. There's another type of externality called a negative externality, and that's where my decisions to do something hurt my neighbors if I do more of it. So a negative externality is something like pollution. The more stuff I make, the more pollution my factories emit. The more pollution washes downstream or upstream or across the river to all the people who live around my factories. And all of them are hurt by that pollution. So pollution is called a negative externality. A negative externality here you'd have the private demand curve, in a sense, further out. Social value is less than private value. You'd have the reverse situation where with pollution, if you have a pollution in there, the private solution is too high. People produce too much because they're ignoring the impact of their choice of production upon all the people who live around the factories and the pollution that affects them. In this case, though, we've got a positive externality, and what we'll see is that the socio-optimal quantity is greater than the markedly provided one. Right? The social value of mowing my lawn is higher than my own private value. Okay, think about an externality, an example of this. We might talk about immunization shots for children. Right, so this one also the book covers, I like it. So there's a private and an external value to parents getting their children immunized. So the private value of immunizing my child for some disease is a reduction in the probability of my child getting ill, which could be quite high. But in modern westernized societies, think about it. Who do you know who has whooping cough? Answer is probably no one. So what's the probability that my child will contract whooping cough from someone I know? The answer is probably not very high. So there's a private value to getting immunized, that's my child won't get it. But there's also an external value to my choice to get my child immunized. And that's the value of, well, if I'd immunized my child, then other people are less likely to get whooping cough. Because my child won't get it, so therefore my child won't be able to pass it on to other people. So while my choice to immunize my child has a private benefit to me of lowering the chance of my child getting sick, it also has a public benefit or an external benefit of reducing the chance that my child will pass on whooping cough to 22 possible million Australians. Now think about it. Even if that value or that probability is very slight, you multiply it by 22 million people, that can be a big value. So the external value of immunization can be quite large. Because if your child gets it, your child could then pass it on to a lot more people at a very large social cost. So my choice to immunize my child potentially affects 22 million other Australians. Now, okay, there's the value of immunization. What about the cost? Because again, we think about demand and supply, right? The cost of immunization, well, the immunization shot itself is trivial, but there's a potential side effects from immunization, right? Which can include very severe reactions, permanent disability, and death. So I'm sure all of you have seen newspaper reports about children killed by immunization programs, and it happens. Some kids just react very badly and they die. So what will a parent focus on? Well, a parent might just say, I simply don't give a shit about 22 million people. I care about my child. Because my child is right there, and 22 million other people is just some kind of figment. They're out there. I may not know them, I may know some of them, but I certainly don't know all 22 million. So I might choose quite rightly in terms of my own sort of social values and my ethical purposes, that I will not immunize my child because I don't want to expose my child to a risk of severe harm. And in fact, there are lots of parents who make that decision. But when they make that decision, they're in fact increasing the probability that 22 million other people might potentially contract something from their child whom they chose not to immunize, such as all of the 23 other kids in the daycare program that they're putting their child in. So your child picks up whooping cough from someone, and then your child goes into that daycare program and starts to cough around 23 other children. That's an externality, right? You're imposing, by your choice, you're imposing a cost upon other people. So in this case, what we have is the net social value of your choice to immunize your child is much greater than the private value to you. It's a cost of, the potential of giving it to 22 million other people. So what we might expect, and what of course we see, is that too few parents choose to immunize. Because it's just like my lawn mowing situation. I may not necessarily care what the people up and down my street and what their property values are. People may not necessarily care about the 22 million other Australians who are put at risk because of their choice not to immunize their child. Now, and there's also an even problem where this becomes even more extreme, and that's called the free rider problem. Now, the free rider problem, called a free rider because what we're saying is that I benefit from everyone else's choices to immunize their children. Right? That's the external benefit to me. And the more children out there get immunized, right, the more difficult it is for a disease to catch hold in a population. So diseases find it very hard to catch hold in populations where, say, 90% of the population is immunized. Immunization doesn't have to be 100%. So those public health officials are actually a bit wrong, well, that they purposely don't tell people this stuff. But immunization programs work very well if 90% of the population is immunized. 100%, the actual benefit to going from 90 to 100 is not so great. But then what about if everyone decided that they wanted to not immunize their child, but they'll benefit from everyone else being immunized, right? The ideal situation for you would be is everyone in the daycare center got their whooping cough immunizations, but you didn't give it to your child, right? There's almost no chance of your child getting whooping cough because it's not going to spread in the population now, and you don't have to run the risk of your child having a severe reaction. So those are called free riders. That's people who are trying to benefit from a situation without any input themselves. If there are lots of immunized children around, the value to me of getting my child immunized is actually quite low. But of course then the problem is, well, what if everyone thought like that? And what if no one got their children immunized? Well, then we'd be back in a situation like the 1930s, where there are epidemics of these sorts of things like whooping cough. which potentially can kill tens, hundreds, even hundreds of thousands of people. Right? So what do? Well, typically we have simply government regulation. It's simply not an option. If you choose not to immunize your child, certain things will come into effect. Another case where we're thinking about market failure. And remember, the market failure here is that there's too little immunization going on. The quantity is too low because we have this positive benefit.